Hello, my name is William Jackson Klein. I'm in section K-12 of Physics 2212, and this is Lab 2, Magnetic Field of a Bar Magnet. The purpose of this lab was to determine the distance dependence of a magnetic field due to small bar magnets. This lab focuses on magnetic fields. Some of the main principles are the Biot-Savart law, which is an equation that gives a magnetic field given the r vectors and the moment vector. Some of my results, I found that my value of n, which is part of a formula for distance dependence, was approximately negative 2.67. The expected value is negative 3. So my value was close, but there was still some error present. And my experimental magnetic field at the 45-degree angle was also very similar. I will go over those exact numbers later in the presentation. Some notes and assumptions for this lab. The system was defined to be the magnet, the earth, and the magnetometer. Just because the only two forces that were assumed to be detected by the magnetometer were the magnetic forces from the magnet itself and the earth. During the experiment, the phone was flat on the table. Its vertical axis was along the north-south axis, and the magnet was flat. However, its longitudinal axis was parallel to the east-west axis. Some potential sources of error, mostly human error, such as accidentally moving the phone or moving the magnet, or just some errors in measurement, because a lot of these, for certain data points, had to be very precise, so there could be some sort of error there. Some of my data and results. Here I show my calculations for mu, which is the magnetic moment. In this graph here, which plots my data, the y-intercept in the equation is equal to natural log of k, and then I solved for the value of k, which is equal to mu naught over 4 pi times 2 times the moment. And then I simplified that down and solved for the moment, which I got to be 4.531. And the n is just the slope of the graph, which in my data was negative 2.67. And here's my Excel file with all my numbers from my different trials. And it also shows the net magnetic field of the 45-degree angle in the very bottom right. Some questions. When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction, and as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. My computed 45-degree value is very close to my value for my glow script model. In the model, my value was 4.39 times 10 to the negative fifth, while based on my trials, my measured value was 3.26 times 10 to the negative fifth. This is very close, however, there was some error present, which I already went over earlier. If I hadn't compensated for magnetic north in my experiment, the net magnetic field wouldn't change, but the magnitudes along the different axes would change. This is just because it's still in the same location. So if you find the net magnetic field based on the different axes, no matter what the orientation is, it's still going to be the same as long as the location doesn't change. However, if it started out being mostly in the X and you rotated it, it could be mostly in the Y, or there are a million other situations, but the absolute value of the net field remains the same. If the experiment had been repeated with 2 identical magnets instead of just the one, the magnetic field would have likely been greater than if there had only been one. Okay, so here is my glow script model. It shows the magnetic field at different points. The orange ones represent the fields on axis. The cyan ones are at points perpendicular to the axis. And the magenta one is at a 45-degree angle on the X and the Y, which is why it looks kind of far off and smaller in this one. And my link to my glow script model is in the description. My conclusion, my calculated n value, magnetic moment, and 45-degree magnetic field were all very close to the expected values, which, although there was still some error present, this did give me a better understanding of magnetic fields and their distance dependence. It was very neat to see how the magnetic field in each direction changed as I moved and rotated the phone. I found that very interesting, and I really enjoyed seeing the increase in the change as I got closer to the magnet versus farther away. This lab taught me how the magnetic field changes at different points relative to the source. I'm very glad that I got to experience this, and it really did give me a much better understanding of this topic. Thank you so much, and I hope you have a great day.